My name is Rob Edwards, Dr. Rob Edwards from Loughborough University. I head up the EWIN project. My expertise is really radio propagation, so useful to this project for looking at how sensors talk between each other on the banks of rivers.
Hello, my name is Raúl Aquino Santos. Currently, I'm professor at the Faculty of Telematics in the University of Colima in Mexico. I was responsible of the embedded teams in Colima. Also, I'm in charge of the postgraduate student here in the Faculty of Telematics.
Hello, my name is Tania Rodriguez. I collaborate in a EWIN project in logistics. I work in logistics projects. So, thank you.
Hello, my name is Oliver Mendoza Cano. I'm a professor at the University of Colima. I was in charge of the water team and the interaction with stakeholders here in Mexico within the EWIN project. And thank you. I'm an expert in water technology and in the engagement with the civil infrastructure and public health.
Okay, thank you very much, everybody. So my name is Professor Paul Muntz. I'm the Chief Scientific Advisor at the Department of Business, Energy and Industrial Strategy here in the UK. And I'm going to be kind of leading us through this afternoon's discussion, finding out, I guess, what EWIN was and what it delivered for people. I guess that's what we're going to under wraps. I don't know who wants to start, really, and tell me a little bit about what the project and what the research was trying to address and why it was particularly urgent that you need to address it. Who is it? Is it going to be Robert or is it going to be Oliver to start?
So I'll kick off, I think. So in a nutshell, EWIN, which stands for Emergency Water Information Network, was really a project designed to look at the problem of flood prediction. In a lot of developing countries, you get this situation where the first thing they know about a flood is when it's upon them. In many countries, they don't have any infrastructure or next to no infrastructure to detect floods. And essentially, the impact on people's lives can be massive. With climate change, it's becoming a greater and greater problem. For example, there was something like 192 incidents in 2021 involving floods. And it's massively disruptive to the way people live. So even small amounts of time saved in warning people about impending floods, where the water's coming from, can make a huge difference to people's security, people's health and their prospects, and also the infrastructure, all of the infrastructure of vast areas of countries like Mexico. This particular part of Mexico is rather special. I think Oliver can tell you a little bit about that.
Yeah, I'd love to understand the Mexican context of this. Oliver, is flooding a real problem in Mexico? And as Robert has hinted, what was special about the area that you were looking at?
Yes, thank you. Yeah, the thing that for making the experiments on all the EWIN project here was really interesting because we have an active volcano just near Colima. So we have also the problem of lahars. We have a very right slope into the terrain. So we have these problems which is called flash flooding events. So you cannot certainly know that you're going to be flooded in certain areas. So having the technology that EWIN made possible was really interesting because we constructed a network that wouldn't be possible if all the team and all the UK support was there. So I think all the interactions were really impressive, and all the stakeholders were really involved, even the army, all the forces which are in charge of the people safety.
That's really interesting. So I mean, Tania, you said earlier in introduction you were involved in the logistics of this, it sounds like it was logistically challenging to get the sensors out there. Tania, is that true? Was it logistically challenging to get the sensors out there?
Well, during the EWIN project, I collaborate in the organization of 2 workshops. Mm-hmm. In the first workshop, we organized workstations with the 3 teams: hydrology, communications, and embedded systems.
Okay.
In addition, businessmen, representatives from the Colima government, students, and researchers were also involved in the first workshop. The second workshop was carried out with the same stakeholders. It should be mentioned that the 3 teams made presentation of their progress, which were very impressive for the people that was participating in that workshop, and allowing the media and people representing the government of Colima to see the project in operation. It's not easy to work with 3 different teams, with people that their knowledge is high and they know that many information is important, but it was a very good experience for me. Interviews were made in the second workshop with the member responsible for the project. We invite to local and national television and newspapers, so they got informed what way for EWIN. Was interesting. I was happy to work with all of them, where I met valuable people with all their knowledge about improved safety and flood prevention. So
yeah, it's important to have that stakeholder group, isn't it? I mean, yeah, I'm struck. I've had a number of these conversations now, and actually the message coming across. Yes, we've got technology, and technology gives us insights, but unless we have people, unless we have stakeholders, unless we have outcomes that are real and on the ground, then actually we're not going to achieve anything. So technology on its own is useless. It's only technology and people that make results. Raúl, I see you nodding vigorously. Do you want to come in on this point?
Of course, thank you. First of all, I say I'm very proud to participate in the EWIN project under the leadership of Professor Robert Edward. Let me just focus what we are working on. Our challenge is natural disaster, specifically with hydrology problem. So according to the Sendai framework, the disaster risk management is one of the challenges topic around the globe. So we focus in this project in technology because we are in a living lab, as Oliver said, because Colima is in hilly position. We are in the middle of the volcano and the sea. For example, in 100 kilometers, we have more or less 2 kilometers high. So this it's a very challenge. So we develop, as Oliver said, the infrastructure using Internet of the Things technology, drones, and more elements. For example, we integrate weather stations, hydraulic station, pop-up devices, drifters, drones, and we create a platform in real time and for future use. So the hydrology station we developed from zero to the first prototype, and we connected this hydrology station in a specific position that Oliver and his team set up, because it's the hydrology problem where to put this sensor. So we connected the sensor by cellular technology. Also, we integrate meteorological station connected to the cloud using our own servers, and we are sharing real time with stakeholders. For example, we are now the government, the civil protection, responsible in each local part of Colima, and everybody has information in real time. Also, we can share the information around the world because it's using the internet. And this is the first step so far. So we are now in the second step, but probably I can add later the next step.
So, I mean, actually, all three of you are painting a very vivid picture of this. So an Internet of Things, enabling people, as Tania has said, a real problem in Colima with the volcano and the drop. Now, Robert, what was novel about this technology, or was the fact that it was all deployed together the key, or as Tania said, is it the stakeholders? Can you paint that picture of kind of how it all hung together as a system, I guess, really?
Okay, so the problem in third world countries is that they can't afford the infrastructure. So essentially, you have to have a system that can be deployed very quickly, but also it's got to be cost effective. So these technologies were put together from commercial off-the-shelf units that had never been seen in such a network before. The prototype system that we used to study in the Colima area had 7 active nodes with it, plus the drifters, which are the pop-up nodes that we've actually put into the rivers to measure river flow. They were designed to measure river flow during floods, which is a tremendously difficult thing to do. The European method is to build gauging stations that measure water changes through history over continual periods of time. They're made like bomb shelter sites. They're very expensive and they're designed to stay in place. In third world countries, particular areas like Colima, nothing can withstand a flood. Essentially, the technology gets washed away. So the system had to be designed to be put in place in the dry season when you can have access to the terrain, and designed to be used in the wet season. And Colima's unique in that because of its rain and because of its altitude, you're almost guaranteed to have an event that you can measure. And we had several during this particular period. The other thing to bear in mind is we have about 0.3% of disasters of this type in Europe. They have about 10% in the Americas, and all the rest is in Asia. But you can't work there because it's not necessarily safe. So Mexico offers this halfway house of high probabilities of disasters that you can study, as well as being safe enough for our scientists to work there and pass on their knowledge. The other part of it is a large part of the project was technology transfer. We were able to create a water team that's still there in Colima, and also a radio team that's still there in Mexico City. And both of those teams, combined with the UK team, can implant their techniques and measurement systems anywhere in the world now. So when Raúl was saying this is stage 1, we're now able to transplant the knowledge that we have into other areas and study other areas like India, for example, where they have terrible troubles with floods, and also China when those situations occur.
So an incredible, in a way, I think, Robbie, you're saying a paradigm shift in the way that you can do flood monitoring, because moving away from historical records and to a rapid response system with off-the-shelf Internet of Things type technology, I think, as Raúl described it, which is rapidly deployable. And I'm also very glad to hear, because as a field scientist, I have to say, that I've done many field experiments where I've gone to measure something, because it always occurs. And during the period I went to measure it, it never occurred. So I don't wish any, to be frank, I don't wish floods on anybody. But it's good you've got it. So Oliver, Raúl, what did you learn from the study then, really, in terms of flood response and the technology? I don't know who wants. Oliver, do you want to come in on that?
Well, I think I learned a lot of things, as Raúl said, with the leadership of Professor Edward Roberts. Was really interesting. Most of the important things were on the workshops. I can tell about the 2 different groups that we were involved in, which there were the government and the stakeholders and all the institutions that I told you before. So we made 2 different scenarios, for example, where a storm is coming and what are the preparedness that we have to make in order to get the people safe. And you have the EWIN infrastructure just helping the decision makers. And the other group were doing like a measurement of the real damage in which certain flood levels could affect this infrastructure. So we cannot go to the hospitals if we need to. We could lose some energy power in some areas. So that was really, really interesting in terms of how to react when a storm is coming. But also you can see in real time how the levels of the rivers are, and how are the rain in certain areas. So as Raúl said, the EWIN systems provides tools to storage the information and to make models of prediction, which is one of the big goals that we are in terms of having more and more information and deal and work with artificial intelligence that Raúl can tell you more in order to be in the next steps. So we also made some resilience measurements, we made experiments, measurements too, in which were involved drifters and the stations that are in the rivers, and also the atmospheric ones. Yeah, it was really, really interesting on the project, and all the students that were involved also are really excited still now. Yeah.
Wow, I mean, it's a very, very kind of comprehensive set of people and ideas and models behind the infrastructure. Raúl, Oliver said learning about AI as well. What was the role around that sort of element of using the data as well?
Yeah, thank you, Professor. Yes, as Oliver said, I learned a lot of things from Professor Rob. This is not the first project that we collaborate. We had already at least another project before. So but this is a huge project. Now we integrate, as Rob said, 3 teams from UK and 3 teams from Mexico. Right. So yeah, this was the first experience is to learn from hydrology a lot of concepts new for me, to be honest. So because I'm more focused in IoT, but in my area, and vehicles, drones, and everything, but not from this kind of application, floods. So we learn and we start publishing papers, of course, with the help, with the support, students, with the support from stakeholders, from many people around, and we publish papers. One of the papers, the chair of the focus group on artificial intelligence for natural disaster management from the International Telecommunication Union read the paper. She contacted my student. My student told me that kind of relation. I was contacted with her. She invited me last year in March to the huge conference to the globe about natural disaster management by using AI.
Raúl, that's a great story, isn't it? It's a great story of how a project and empowering scientists and taking technology infrastructure and putting data together, an international collaboration has mushroomed. It's mushroomed, hasn't it, much beyond the original EWIN project, the original project, and shows the power of these sort of collaborations. Absolutely. So, Robert, turning to you, what do you feel the longer-term impact of EWIN would be? I mean, Raúl's painted this global domination picture, I think, coming out of the project.
Really, the main shift I'm hoping for in terms of policy is to stop people sitting around waiting for floods. The big problem with floods, of course, is you don't often know where the water's coming from, and systems like EWIN can tell you that. Once you know where the water's coming from, you can begin to engineer solutions to where the water sits and how it behaves. Currently, most of the world, I think, is sitting back a little and waiting for disasters to happen. I think we have to be a lot more proactive in terms of the way we address climate change. Climate change is not now a slow thing. It used to be creeping up on us really slowly. It's now with us. And it won't be long before we're seeing these sort of shifts in the UK. So I think if from projects like EWIN, we can get a sense that things are important and need to be done quite quickly. The other side of it is that it doesn't have to cost the earth. You can make a big difference with quite low unit cost if you're using this type of technology. So for example, one of the sensors that we're looking at out of EWIN is a Doppler sensor. You'll be familiar with Doppler. We're using Doppler to collect spectrograms, and then we're using pattern recognition, which I guess falls into the fringes of artificial intelligence, to recognize flood states. The sensors for Doppler cost about £15. The whole unit plus the sending unit costs another £20. So for under £40, you can get a device that says there's something happening here which is really odd, and we ought to go up in the hills and do something about it. I think from the point of view of the main change that the project's come about is looking at floods in a very different way. You don't just have to sit around waiting for them. You can try and predict how they're going to happen and when they're beginning to happen.
So in a sense, it's technology enabling flood prediction, but in a cost-effective and IT-enabled or way as well. Oliver, from your perspective, what was the longer-term impact out of the project?
Yeah, I think one of the most important long-term effects are the education, because people is not really familiar in these third countries areas with this kind of information. So one of the very big goals of the project was to make visible for the whole community where the hazard was. I mean, with your cell phone, you can go to the EWIN portal that the Raúl's team developed, and you can see how much rain is in certain area. So you can see also like a green, yellow, red light in which you can prevent your own safety. I mean, this education perspective for the whole community in areas like Mexico, I think are the very big and novel things, because I mean, there's a lot of things that you can see in the real world that even if we see like a big storm coming, you're not very aware of it, because you say, oh, okay, it's going to be a really light rain. But if you see that there's a technology that is saying you that you could be in danger, and even you have the authorities also knowing that, it's going to be easier to prevent disasters. I mean, for example, all the infrastructure things are okay. You can manage with that, but losing one single life is really, really important.
Saving one life is absolutely the goal of any good science, isn't it? If we can save any lives, that is an absolutely, superb thing to do. So for Raúl, for you, what was the kind of longer term impact?
Yeah, now we are working with the standardization with the International Telecommunication Union. We are working with 3 different groups. With data, how standardize this the artificial intelligence for flood monitoring and prediction, but data. The second group is modeling. We can standardize modeling, and the third is the effective communication. How Oliver said, how can we get the society with real data, with effective communication, with working with stakeholders, with government around the globe. So we are working with these different groups, standardize our results in the next month, probably.
Wonderful. So yeah, it's the international aspects. I mean, it's flowing out to the ITU, and that standardization means that, I guess you'll be able to roll it out more cheaply, more effectively, and more flexibly globally as well. So Tania, to begin to round off the conversation a bit, how important was the international collaboration in delivering the outcomes of this from your perspective?
Working with international people makes that they can continue improving more investigation work that Raúl said. And I think it's very good because maybe I just work in the logistic, but not in all research. So I think it will be a good experience for them because they can continue working and improving and trying to find more funds to continue this EWIN project for a better future preventions. So it's interesting to continue to making more researches and still working all together. Maybe their jobs, they are sometimes not involved most of the time, but you can for all the knowledge that they have. It's great to continue making the technology improving better things for all the natural things that continue happening in this world.
Wonderful. That's a great way. Raúl, I mean, I think you've talked about the ITU and the international context. So, I mean, in a sense, it's gone on to a bigger international context. But what did you get out of the partnership?
A lot of things, really, to be honest. But now, with this collaboration with Professor Rob and all my friends right now, we are now collaboration not only with International Telecommunication Union, also with World Meteorological Organization, with the United Nations Environment Program. So now we are going to publish next month one bulletin from the World Meteorological Organization. And this bulletin includes all of the multi-hazard that I told you before. And in that bulletin include our result of the project. So all the globe will read about this project with this bulletin from the World Meteorological Organization. So really, I'm very proud to be part of the EWIN.
Proud and global impact. And one more. Oliver, to finish with you, really, I mean, what are you going to take from the project?
Well, as Raúl said, I have a lot of things to say, but one of the most important are the very special synergy about how all the scientists and all the people and all the decision makers were involved. This was really, really an amazing story that is telling you that we as a whole can construct a very, very useful tools for a better world with the support of people like you, like Rob, like all the whole team that was constructed in order to have a very real solution for our own space, which is the world. So I think this is very, very impressive and very big goal that we all achieve. Yeah.
Well, thank you very much, Robert, Raúl, Tania, Oliver, for sharing your project with me this afternoon. I'm left with a very strong, impression of a really heartfelt team that have worked together on a really critical problem, flooding, and saving people's lives, but also so much that has come from a project in terms of personal collaboration, of stakeholders, of new technology and impact that runs from the local to the global in many respects. So congratulations on what you've achieved. It sounds absolutely fascinating. I hope you can go on and take it even further as part of developing. Very much an international partnership, very much recognized as a two-way international partnership. And thank you for joining me today to talk about your project on our Good Development Conversations. Thank you very much indeed.
Thank you.
Thank you very much, Professor.